is a piecewise function. So it is a piecewise function. And its equation is going to be a breaking point at x equals 1. So you have x less than 1 and x values greater than 1. And since the closed circle is with the top part of the graph, the greater than gets the equal to as well. We have to also realize, though, that the function changes at -2. So I need an additional breaking point at -2. Because it changes from a horizontal line to a linear line. So you have x values between -2 and 1 being -2, but then we have all x values less than -2 or equal to -2 coming from this equation of the line right here that has a slope of 1/1 and would go through the origin. So that's x for x values less than -2, -2 for x values between -2 and 1, and then for x values from 1 and on, it goes back to that function of x. Good? In example number 2, it says identify the type of graph. So that is an absolute value. The graph is open down, so it's y equals negative. And it's going down 1, 2, 3, 4, 5, 6, 7, 8. And over 3. So it's y equals -8/3 absolute value of x, because the origin and the vertex are one and the same. -8/3 is greater than 1, therefore this graph is stretched and reflected. And in number 3, it is a piecewise function. It says give the amount of money earned for working different numbers of hours. How much will an employee earn for working 12 hours? So 12 hours lives between 8 and 16. So you're going to plug into that middle function. So it would be 8.5 times 12 minus 1. And Avery, I saw you had your hand up. What did you get? 101. Good. So they would earn $101 for working 12 hours. So like I said, today all we're going to do is review pretty much everything we've already talked about, but using some of our vocab. So throughout this lesson, I've been talking about a family of functions and a parent function. So a family of graphs is a group of graphs that display one or more similar characteristics. A parent graph is the graph of the parent function. It is the graph that has no transformations. So over to the right are examples of parent functions. You have the identity linear function, which is y equals x. You have the parent absolute value function, which is just the absolute value of x. and you have a constant. Okay, so then we have that the function is what? So on that next page, I pretty much gave you a ton of key vocab words and everything that goes along with those transformations. So a constant function is like y equals c. The identity function is y equals x. The quadratic is a u-shaped graph for x squared. Cubic is x cubed. Those are all what we call the parent functions. And then the translations all directly relate to the translations we were finding with absolute values. So if it's inside the absolute value, it's going to move it left or right. And it's always the opposite of what you see. So x plus h moves it left, x minus h moves it right. If it's outside the absolute value, that's your up and down. If there's a negative in front of the absolute value, it's across x. And if there's a negative inside the absolute value, nothing changes because it's a reflection across y, and that doesn't really affect the absolute value. And then we primarily focus on just compress and stretch vertically. We don't discuss them horizontally. So it says describe the translation and then graph the function. I'm not having you graph quadratics just yet. So I kind of already put this quadratic functions graph up for you. So you can just roughly sketch that based off that this is the parent function. If the plus 1 is inside the parentheses, just like an absolute value, what that means is that my graph is going to shift left 1. So this red graph represents the parent. A shift left 1 is going to move all of those key points to the left 1 unit. So the red is the parent, the blue is our translation left 1. Once again, here is the parent function. So absolute value of x minus 4. That negative 4 is inside. So that is going to move your graph right 4 units. So those red dots are going to go to the right 4. And there's my absolute value graph shifted right from its parent function. So every time we were talking about right 4, up, down, etc., we are always talking about that parent function's movements. So in example 3, this graph has that negative, so that reflects it across the x. So now it opens down, so all of those points get reflected across the x. Okay, like I said, you don't have to worry too much about the quadratics, so you can put an X on example 4. We're not going to worry about quadratics because that's all of chapter 5, so you can just X out example 4. And then look at example 5. So in this case, we have a 1/2 in front of our X. That's between 0 and 1. So my graph is going to be compressed by 1/2. So that means it's vertically fatter or wider. And again, you can see that when you look at the light blue compared to the dark blue, it is below and happening at a slower rate. Okay, example 6, we have y equals 2x. So that dark blue line is the original. So that 2 is in front of my x. So what that means is that this line is going to have a new slope of 2. So that is stretched by 2 for the linear function. It's going to be steeper, therefore it is stretched. And again, you can see the red graph happens much more quickly than the blue. And what we're going to do in example 7 is take away that squared and convert it to an absolute value and talk about all the transformations in terms of an absolute value. So the negative is a reflection across the x. The 1/2 will compress my graph. The -5 will shift my graph right 5. And the plus 12.5 will move it up 12.5. So I'm just going to change my graph to be by 2's so that I can accommodate all of those transformations. I'm going to change it by 2's on x and y so I can apply my slope the way I know. So if it's going right 5, this is 2, 4, 6. So that's in between those 2 points. And then it's up 12, so 2, 4, 6, 8, 10, 12. So it'd be just a little bit above that 12.5. It's reflected, so my slope would be down 1 and over 2. Down 1 and over 2. And you have to keep that same little bit above and over 2 in between the points. Okay, and then in that last one, the negative will reflect you across the x. The 1/4 will compress. That's also your slope. +4 will shift you left 4. And -2 will shift you down 2, making my vertex -4, -2. And it's a -1/2, so it's down 1 and over 4. Okay, so your homework is actually in your book to start preparing us for our test that's coming up. So again, you could go into the Teams chat. You're in the files. There's a copy of your textbook if you need it. So the idea is tomorrow we're going to review, and on Wednesday we're going to take the 2.5 to 2.7 mid-chapter test, because I'm grouping 2-8 in with chapter 3 because it's on linear equations and inequalities. So the chapter 2 study guide is on page 125. So let me get a blank screen up here to write on. You're doing 42 to 53. And then on page 127, (13) to 15, and that's it. So 125, 42 to 53, and 127, 13 to 15. There may or may not be. My computer on Friday was being awful. Let me see if one ended up saving or not.